So Young's double slit experiment made the two sources of light by having a single source of light with just a pinhole and then two slits. And so what we had here was we had effectively two sources of waves from the two slits. And he saw an interference pattern. It turns out you can actually see an interference pattern with just a single slit. And that's reasonably easy to understand because the waves coming out of our single source here don't just come from one single point, they come from all the different points across the edges of this slit. So the light coming from this point here and the light coming from this point here are going to make their own little interference pattern. And if they happen to be exactly half a wavelength out of phase, then you're going to get destructive interference and you'll have no light coming through there. When you have interference from just a single slit like that, that's called diffraction. So when you're calculating what kind of diffraction pattern or interference pattern you expect to see, you can't just take any 2 points of the light. You have to take all the light that's coming through the slits or getting past the obstacle. And that means you have to add up all these different waves together. And each of those waves is going to travel at a slightly different distance, and so you're going to have to add them up with slightly different phases. Now that math can be a little bit complicated. There are some special cases where you can divide up this region where light's coming through into pieces and say, well, each piece on the left-hand side of the middle exactly cancels with one of the pieces on the right-hand side of the middle. And if you get that exact calculation for each little piece of light, then you can say, therefore, they're all going to cancel together, and therefore you'll definitely get destructive interference there. But in between the constructive and destructive parts, it can be a little bit complicated. But it's straightforward to understand why you're getting that pattern, and if you had the time, it would be straightforward to calculate.